Okay, the system, this is part C and D of question number 7 from January 2017. We've done part A already. And this is now part C. Okay, so this is question number 8, part C we're doing right now. I've just copied what we know from the diagram of the pulleys in this section here. So the system is released from rest at t equals 0 seconds. At time t 1 seconds after release, Q strikes the ground but does not rebound. The string goes slack and P continues to move up. Find the value of T1. Okay, so first of all, we're going to deal with Q. We're going to find how long it took for it to reach the ground, and we're going to use suvat as we have this constant acceleration that was there as the string was tight. So we're only dealing with the part until before Q hits the ground. Okay, so once Q hits the ground, in the time before it hits the ground, you have a constant acceleration of 1.4 meters per second squared. So we know the distance it falls, which is 10.5 meters. We know the initial speed was 0. The final speed we don't know. The acceleration we know is 1.4. I'm taking down as positive because it's moving down. And the time is what we have to find. That's T1. So we're going to look for equations which deal with S and U and A and T. S and U and A and T. Okay, so we've got S equals UT plus a half AT squared. Okay, S and U and A and T. We don't know what V is. It looks like that's what we're going to use. So we've got 10.5 is equal to U, which is 0 times T, so that's 0, plus a half times 1.4 times T squared. Okay, so you have 10.5 divided by 0.7. T squared is going to be 10.5 divided by a half of 1.4, which is 0.7. So T will be, let's work that out, 10.5 divided by 0.7, and so T is going to be the square root of 15. Okay, which gives us 3.87. Okay, T is the square root of 15, so T is equal to 3.87 seconds. That's T1. Okay, there's the answer for T1. Okay, so now for part D, it says at time T 2 seconds after release, P comes to instantaneous rest. Okay, so now basically what's happened is once so you've got basically P is undergoing 2 different types of situations. Okay, so first of all, what we have is we have the first situation when P is being pulled up. You've got tension in the string and you've got its weight, which is 3G, and this is 33.6. Okay, and it goes up until T1, which is 3.87 seconds. That's when Q hits the ground. Once Q hits the ground, the string is not tight anymore and the tension has gone. So the second situation is without the tension. So you just got basically this and 3G, and that's it. Okay, so we know that what do we know? We know that so we know that the acceleration now is just G. Okay, and it's acting downwards. Okay, and we know S, U, V, A, T. I don't know how far it's going to go up. We know the initial speed is what it was when it started out. Once this broke, so we don't have to find that maybe first. We know that the final speed is 0. We know that A is going to be negative G, because it's going upwards. It's actually going upwards, it's moving upwards. Okay, but the G is acting down. And T, we don't know the time either. So we've got to find this. This is T2. Alright, so let's deal with this question. So what we need to do here is I think we need to find out the speed You see the speed of Q as it hits the ground is equal to the speed of P at the point where the string breaks. So the initial speed of P. Okay, so if we find what V is from here, now we know V is equal to, V is equal to U plus AT. So I'm just going to use this to find the final speed of Q as it hits the ground, which will be the initial speed of Q which will be the initial speed of P once the string breaks. Okay, so you got V equals U, which is 0, plus, and you got 1.4 times the time, which is 3.87, or root 15. Okay, so the final speed was 1.4 times root 15. So times 1.4. That gives you 5.422. So V is 5.422. 5.422. That's meters per second. That's the final speed of Q as it hits the ground, which is, in this case, the initial speed of P once the string becomes taut. So 5.422. Okay, so now we need to find the time. We've got V equals U plus AT, we can use that. Okay, so we have V equals U plus AT. So we know what V is. It comes to rest. It's instantaneous, going up, and it's going to stop before it goes down again. And U is equal to 5.422. That's the V, that's the U for the second situation, once the string has become loose again. Okay, plus A, which is minus 9.8 times T2. Okay, so we end up with basically having 9.8. Oops, what happened there? Strange. 9.8 times T2 equals 5.422. I don't know where the extra 2 came from there. And then we know, T2 will be 5.422 divided by 9.8, which should give us the correct answer. So there's that divided by 9.8, which gives us 0.5532. Okay, 32. Okay, so that's the time, second time. That's the time after the string became loose. So T2 is the time after release. So you've got T1 plus, this is not actually T2 actually here. I shouldn't have called it T2, because T2 is the combination of T1 and this extra time. So I should have just kept this as T actually. So I'll just do that. This should be T, not T2. Okay, I'll just call it T. Okay, that's T, and that's T, because T2 is the combination of this and the initial time before P hit the ground. So this is T, and this is T. So now we can say that T2 is equal to T1 plus T, which is 3.87 plus 0.5532. Okay, so you got this plus 3.87, which is root 15, and that gives you 4.43 seconds. That's the total time it took for which one is it? For P to come to instantaneous rest. So it's gone up until Q hit the ground. So it's moved up 10.5 meters. Okay, then that's the point where Q hit the ground. Then there's no more tension in the string because it's become loose. So it goes up with just the force of gravity stopping it, and then it takes the extra time for it to come to rest. So 3.87 seconds is the number of seconds it took to rise up 10.5 meters And the extra amount we found, which was 0.5532, was the time it took for it to come to rest, as it's not being pulled by the string anymore, just gravity is acting, pulling it down. Okay, so there we have the answer for part C and D, and I'll do the answer for part E in the next video.